We spend all day using apps on our phones and computers, but we rarely stop to think about what separates the good ones from the truly frustrating ones. Today, we're going to pull back the curtain on that invisible craft, the hidden world of software quality, to figure out what actually makes the tech we rely on, well, reliable. So just think for a second about your absolute favorite app. The one that just works. It's fast, it's smooth, it never crashes. It does exactly what you expect every single time. What is it that gives you that feeling? That sense of quality? I can tell you, it's definitely not magic. It's the result of a very deliberate and honestly, a pretty fascinating process. In the software world, quality isn't just a vague feeling. It has a super specific definition: fitness for use. And here's the really cool part. It's a two-sided coin. On one side, it has to be fit for your use. It has to meet your needs as the customer. But on the other side, it also has to be easy for the developers to keep working on, to evolve and improve over time.
All right, so here's our game plan. First, we'll look at this whole quest for quality. Then, we'll get into the two most important questions in software. We'll face what seems like an impossible task, find a clever way to divide and conquer it, and finally, look at how teams make sure that quality actually sticks around. So, let's start with that quest. This isn't just about developers crossing their fingers and hoping for the best. It's about having a formal process, a structured discipline, for making sure the software is truly fit for use.
And that discipline? It's called quality assurance, or QA for short. The best way to think about QA is like the official playbook for a sports team. It's the entire set of rules, processes, and standards they follow to build a high-quality product, right from the very beginning.
Okay, so this is where it gets really interesting. Because inside of QA, there's this central conflict, this tension that every single software team has to deal with. And it all comes down to two very different, very fundamental questions.
The first question is this: did you build the thing right? This is all about the nuts and bolts. Is the code clean? Is it efficient? Does it do what the technical blueprint said it should do? It's all about the craftsmanship. But then, right on the heels of that first question comes another. And you could argue it's even more important. Did you build the right thing? See, this question changes everything. It asks, hey, this thing you built, this perfectly crafted piece of code, does it actually solve a real person's problem?
And this perfectly captures the two core jobs of quality assurance. Verification is asking, are we building the thing right? That's just checking against the technical specs. But validation is asking, are we building the right thing? Making sure it's what the customer actually wanted. You can't have real quality without doing both.
Now, you might be sitting there thinking, well, this seems simple enough, just test everything. But if only it were that easy. This leads us straight into the villain of our story, the impossible task of dealing with just overwhelming complexity. Here's the hard truth. For any modern app, it is literally impossible to test every single button click, every text entry, every possible way a user could interact with it. The number of combinations is astronomical. You can't do it. There isn't enough time. Just imagine trying to do this by hand. A developer adds one tiny new feature. Okay, now a poor human tester has to go back and manually recheck the entire application, just to be sure that one little change didn't break something else. With every new feature, the whole process just grinds to a halt. It's completely unsustainable.
So, if testing everything is impossible, what's the answer? Well, you don't work harder, you work smarter. And if complexity is the villain, then this right here is our hero, the divide and conquer strategy.
The idea is actually brilliant in its simplicity. Instead of trying to test this giant, monstrous application all at once, you break it down. You test it in layers, starting with the tiniest little Lego bricks and working your way up until the whole castle is built. This strategy really has three main layers. At the very bottom, you have unit tests. These check one tiny piece of code, a single function, all by itself. Once you're confident the individual bricks are solid, you move up to integration tests. This is where you check to make sure those bricks actually fit together correctly. And finally, you have system tests, where you step back and look at the whole finished program to make sure it's doing what it's supposed to do.
So building a quality app is one thing, but what about keeping it that way? How do you maintain that confidence as the software changes and evolves over months or even years? This is where our final pieces of the puzzle come in.
One of the most important metrics teams track is something called test coverage. It's pretty straightforward, really. It's just a percentage that tells you, of all the lines of code in our application, how many of them were actually run by our tests. It's a way of seeing how much of your app you've actually looked at.
So, for example, a team might see that they have 80% test coverage. That means their tests are running through 80% of the code, which is pretty good. But it also shines a big spotlight on that other 20% that remains completely untested. It shows them exactly where their blind spots are.
But, and this is a huge but, it's so important to remember this. 100% test coverage does not mean your application has 0 bugs. No way. All it means is that every line of code was run by a test. It doesn't mean it was run in every possible situation or that the logic itself is actually correct. It's a useful guide, for sure, but it is not a magic bullet.
And that brings us to the ultimate safety net, regression testing. This is amazing. It's the process of automatically rerunning all your old tests every single time a developer makes a new change. Its only job is to catch regressions, to make absolutely sure that the shiny new feature you just added didn't accidentally break something that was working perfectly fine yesterday.
So the next time you open an app and it just feels right, it's fast, it's reliable, it just works, take a second. Think about all that invisible work happening under the hood. The constant battle between verification and validation, the layers of unit, integration, and system tests, and that always-on safety net of regression testing that came together to create that seamless experience for you.